Hey gang, I'm back for the back of this worksheet dealing with exponential modeling. And again, we'll look at population. This time we'll go across the river to Conshohocken. And in 2000, the population was 8,000 people. And by 2010, it increased to 8,400. So this 2000, that's my initial population. Again, sub-zero indicates time zero or initially. That's what my 8,000 is. Sorry, I got to move that over here. My bad. How did I do that? Here, that's P sub zero. And 10 years later, I get 8,400. That's P of 10. So I want to find an exponential model. So, hey, let's write down our population growth equation. It's my population. I started some initial population, 1 plus R to the T. And let's plug in what I got, right? I know my initial population, I said, was 8,000. My growth rate, guess what? That's what I don't know. So that makes this fairly difficult. They didn't say goes up by 3%, goes up by 4%. That's really my unknown, right? But how long did it take? It took, 10 years by 2010. So in 10 years, the population was at 8,400. So over here, my P of T, really my Y value, is 8,400. So if I can solve for R, I can write my equation, my growth model, because I need to know that percentage growth per year. And of course, how do I get R by itself? Well, you got to get 8,000 out of there. You got to divide by 8,000. So again, hey, divide by 8,000. I'll do like the algebra teachers do, divide by 8,000. So I get 8,400 divided by 8,000. This shakes out on a calculator to 1.05. It's really 21 over 20, which is 1.05. On the right, I get this 1 plus R to the 10th. Now, be careful. This is not really exponential because the variable R, what we're solving for, is down. It's not in the exponent spot. So I'm not logging both sides, despite what you think. This is a power equation. And the way you get rid of powers are with roots. So to undo a 10th power, I actually need the 10th root on both sides, which, what is the 10th root? To get rid of 10, I just need to do 1/10 power. How about that? So to cancel out 10th power, raise it to the 1/10, but you got to do it to both sides. So on the right side, I'm going to get 1 plus R, and on the left side, I get 1.05 to the 1/10. You got to jam that in your calculator. A calculator will eat that up, and you get 1.00489. I'm going to stop it there, although you should probably keep those decimals in your calculator because it does keep going. So guess what? That actually gives us our equation. So I'm going to go back up here. So our population at any given time, again, is that 8,000. That's where we started with. But this 1 plus R, I don't even have to solve for R. I just leave it like that, right? This 1 plus R, the base of my exponential is 1.00489. And again, to the T, right? That's how so it's a slow growth. Oops, sorry, 1.00489. And again, they said, well, hey, use this. We're on part B now, I guess. I guess that was the answer to part A. We found the exponential model. That's surely the hardest part. And then they want the year 2015. Don't forget, we started at the year 2000. So this is year 15. So for part B, I'm going to plug 15 back into this. And it's 8,000. And then this 1.00489 jacked up to the 15th power. Again, all of this you're going to need a calculator for. But the population should ramp up to over 8,600. I guess I'll be as close as I can, about 8,607, right? Okay, so that's one example. And then here's another one where we're actually going to give you the model. And this time we're going to use the base of E, that same E we've seen, which is the base of the natural logarithm. Don't forget what E is. It's just a constant. It's like pi. It's about 2.718. Shows up a lot. And here they said, hey, the cost, the median cost of a house since 1990 is modeled by that, where X is the number of years since 1990. Again, we're using that convention, so our powers aren't ridiculously high. So you can see in 1990, the median cost of a house was about 130,700, right? It just goes up from there. So you got to pick a good window, you know, whether you're on Desmos or if you're on your TI-84. I'll tell you what, if you're on a TI-84, I'm going to set your window for you just to help you out. My minimum should be 0, because again, we don't care about negative years. My maximum value should be about 30 years, right? I don't know how far in the future you want to look to, but 30 years seems far enough. And X scale on your 84, I don't know, you can make it 5, you can make it 10, those just affect the little tick marks. Your Y min and Y max, this is the cost of a house. You know, these are just suggestions, but I would start about 100,000. You're not going to have a house cheaper than that. And let's go up to like 300,000. And again, the scale, it depends on how many tick marks, how you want to mark off your graph. It's up to you. 50,000 seems reasonable, but if you did it at 100,000, you just have less tick marks. And your graph shakes out to something like this, right? I'm doing a terrible job here, but this is what it looks like. Again, at 0, you're at that, what is it, 130,700. And then of course it's the slow growth because it's population growth, right? Actually, it's not population growth. It's the cost of a house, right? And, you know, you could plug in some values. Now here, they say use the graph. So on an 84, you would just kind of scroll along, or you could literally plug in X equals 10. You know, X equals 10 would be for the year 2000, right? And for the year 2010, X would be 20, because that's 20 years after 1990. You could plug those in, you could trace the graph. On Desmos, you could literally, you know, move along the graph and kind of look at the Y coordinates. Or, you know, algebraically, you could just plug in 10 and 20 either way. But if you plug in 10, it takes you right about there. And 10 gives you about 171,212. So that right there is the population in 2000. I keep saying population. That's the cost of a house. I'll even put dollar signs in 2000. And at year 20, you know, if you put this in your, and by the way, I encourage you to just not watch me. Use Desmos and actually do this, or use your TI-84, whatever you have. The cost of a house, the median cost of a house, and again, it obviously depends on where you live, right? About 224, 282 is what I got. And that's the answer for 2010. So, you know, a couple ways. You can plug the number in, or if you're a grapher person or you have a graph, you can just trace the graph and look at the Y values, right? That's the whole point of having a model. All right, guys, I hope that video helps.